Okay, in the last few classes, we studied about the ADT array, and we did some applications on arrays. We did primarily sorting and searching algorithms. In sorting, we studied both order n squared and n log n algorithms. And in searching, we looked at algorithms that were of the order of n and log n. Okay, and we showed, and there are many other sorting algorithms like radix sort and so on, which we will try to cover when we come back to the end of the class. So a array is perhaps the simplest ADT that we have, and we saw that what is an abstract data type now? Going back to recollect, we have a mathematical model called the data model, and we have an informal algorithm that operates on this data model. Then this gets converted to an abstract data type with some pseudo language program, like we have been writing in class all the time. And finally, what do? We convert it to a data structure and operations, a higher level language program that operates and this data structure. Actually, when you look at it, this whole thing about abstract data types, where we said you have a data model and you have a set of operations that operate on this data model. And once again, I repeat, just as procedures encapsulate an abstract data type, encapsulates data. What do we mean that? What do we mean by that? Just like in a procedure, when you're using the scanf, for example, in C, you couldn't care less how scanf was actually implemented. You're only interested in using it. And what do? You just include the interface functions for I/O in C called the standard IO.h. And these functions are available, scanf, printf, and so on, are available in this standard prototypes are available. We include this .h file. And what does the .h file contain? It only contains the function prototypes. What do we mean by function prototype? We just saw the quick sort and the merge sort. That would be something like this: void quick sort and int star a int left comma int right, okay, semicolon. The function will not be there and only the function prototype will be there. Why is the function prototype important? To let you know how to use it. What does it say? It takes as argument an array A and a pointer to the leftmost position in the array, an index to the leftmost position in the array, and an index to the rightmost position in the array. Once you know this, you know how to use quicksort. When we say just as procedures encapsulate functionality, what we mean by this is the following: that I can change the function quicksort, the body of the function quicksort. I can change and say I'm giving you an update. Remember how many times you do an operating system update, right? Are you worried about what the changes are? No. So basically, you still continue to use the function in the same way. So what do they ensure? They ensure what is called backward compatibility. You don't have to worry about how the uh, procedure was implemented internally as long as you can use it as you were using before. Okay? That is the most important point about procedures or functions. Now, what we're going to talk about in abstract data types is we're going to try and do the same thing just as a procedure generalizes. Again, I'm repeating here the notion of an operator. So basically, you have, what do we mean by that? For example, you're familiar with the special multiplication slash minus addition operate on specific data types. You can make this operate on user defined data types. You can also define your own operators. Okay. In Wednesday's class, I will teach you a little bit of C++ to show you how this can be done. On user defined data types. You can have your own data types that is defined and a set of operators that operate on this particular data type. Okay. So now what I'm going to do is, we already talked about the idea of a matrix. We'll make you implement it at some point. Now, I want to talk about the next set of slightly more complicated ADTs, which are considered very basic ADTs in computer science. And these are the ADT list, the ADT stack, and the ADT queue, which are used a lot. And all three actually can be thought of as lists. And this is a general purpose list. You'll see what this can do. And this is somewhat more specialized. It has permits only a part of list operations. It is also a list. And similarly, the queue is another one which permits only a part of list operations. Okay. So first, what is the advantage of using ADTs? I'm going to use a new word now. Your data model can be private and operations can be defined on private data, and implementation is completely hidden, like the scanner, for example. Just like procedures implementation is hidden, we also hide the implementation of an abstract data type. Data can only be accessed indirectly. We'll see how this can be done. And the good part is that, why is this an advantage? The implementation of the ADT can be changed without changing what we call ADTs, interface functions, to the outside world. Functions to the outside world. We'll see how this can be done, okay? Why do I call them interface functions? Because when you're using an ADT, you want to put data into that structure, into that abstract data type. You want to store and you want to retrieve. And these are defined in terms of interface functions. You cannot access the data directly. Okay, that's the purpose of an ADT. So let's talk about the ADT list. Remember, this is different from a linked list. Linked list can be used, which we studied in C, can be used to implement an ADT list. Okay, but need not necessarily be so, because you just want an ordered set of elements. Now, how do we define the ADT list? It is a sequence of 0 or more elements of a given element type. Okay, so what do we mean by this? If I have a list of items A1 up to n greater than or equal to 0, and each element is of some element type. Okay, all right. And what is n? N is the length of the list, and we will assume n is greater than or equal to 1. First element is A1 and the last element is AN. Okay. Now, let us go on. So now, if I wanted, as I said, there is a pseudo language problem, mathematical model. So let us get into the higher level, kind of in between a mathematical model and the program. So I would call it an ADT list, some private representation, private data where we do not know how A is going to be represented, list of element type. I've not said what this implementation of list is going to be. Okay. And then we have some interface functions or functions to the outside world, which these are the operations that one may like to perform. Insert an element X at position P. P. And go to the end of the list. Okay. Locate. Find the position of an element X in the list. Then retrieve of P, retrieve an element at location P. Delete an element, delete the element at location P. get the position of the next element in the list. Okay, and also have previous get the position of the previous element. Element in the list. Okay, various such operations, and get the first element on the list, get the position of the first element on the list. Print all the elements in the list. Print the element at position P. P. And last but not the least, make null. Create an empty list. An empty list. Okay. Now locate, retrieve, insert, and so on. Now, let's see if I want to write a program with all of this. So this is my ADT list. Okay, let's say I say that I have a variable list which is defined to be of type list. Now, let's say that there are P's. So this one, for example, next P gets the position. So there is a variable called, there is some in the interface function, it says it can return something called position in the list. So I could write a variable of type position. And let's say I want to insert elements of some, let us say my element type is something that I have designed. This is a user defined type because I'm the one who wants to put things into the ADT. Now let's say I want to put n elements into the ADT list. So I have this list over here, and let's say n is of type integer. I can write a simple program. So what are the things that I will do? I'll say list dot make null. I have variable I, which is also of type integer, and I'd say I is assigned the value of 0, and while I less than n, do let's say that make null has been done, and I'd say that P is assigned the value of list dot first, location of the first element in the list, there's nothing there. And I can say that while P is assigned this, I can say insert let's say I have some set of variables x over here, or insert x, p, then I can say that p is assigned the value of next of, so it should be list dot insert of p, and this should be list dot next of p, and I is assigned the value of I plus 1 and y. What I want you to appreciate in this is that we have really not worried about the implementation of elements into the list, but given the interface functions, so what did I do? Notice that I defined a user-defined type called list. I defined p as a position because it's returning a variable of type position, just like integer, real, float, whatever. And we said it holds elements of element type, which let us say you have defined because you are the one who wants to, the user wants to put it. Now what I want to do is I just want to put n elements into this list. So what do? I create an empty list. I initialize I to 0. And then I say that I will make this point to the first element in the list. There's nothing there. This creates an empty list. And now I'm going to say while I less than n, insert an element into the list. Then p points to the next element in the list. I equal to I plus 1 and repeat this. Then what could I do? I can say list dot print to print all the elements in the list. Okay. Notice that we don't even know how the list has been implemented. So we'll stop here and we will talk about the